Hello everyone, welcome. So in this video we will be just talking about one question that a given set of vectors is a subspace of vector space R to the power n or not. So the first question, we have given this S, and what is this S? This S is nothing but the set of vectors, right, with given condition. So all those set of vectors that is in the S will satisfy this condition, right? And the question is that if that, so in this set S we will have many vectors, right? Maybe infinite vectors. So we just need to find out if this set S is a vector space of R square or not for this particular question from 1 to 9. So we are just looking at this first question, right? So there are three conditions needs to be satisfied for to be a subspace of a vector space. The first is that zero vector should be there in the set, and the second point is that if you pick any two vector from this set S, and if you add those two vector, then their addition vector, whatever the addition vector will come out, they should also be within this set. They should not fall out of this set. This is the second condition. And the third condition is that if you pick any vector from this particular set, and if you multiply a scalar quantity with this vector, whatever you have picked from this set, then by multiplying that vector, whatever the resultant vector you will get, then that vector also should be in the set. And if these all three conditions are getting satisfied, then we can say that this set is a subspace of R square, right? So I think if you are not aware about this vector spaces, subspaces, then I would say go through my detailed lecture, then you will have the good idea about this. So in this video we will be just looking at the questions so that you have the good amount of practice with such kind of question. So the first question is that if this S is, so I think you should have now clarity that what is the question and what we have been asked, and you should have the clarity about this, what this is representing. So this is nothing but a set, right, with a condition, and just we need to find that all these vectors, if I pick any vector from this set, if I do the addition of these two vectors, whatever I have picked from this set, then again that addition should fall under same set, right? So what this is what we call closed under addition, and the third condition what we call is the closed under scalar multiplication. So we can just go through all this from 1 to 9, and we can just say if it is a subspace, yes or no. Alright, so you see that zero vector will be there in this set. How I can see? Let's say 0 0, right? I have to just check that if this 0 0 is in the set S or not. How I can check? With this given condition. So what this given condition is saying, that whatever the vector that is in the set S, you multiply the first component with 5, and you multiply the second component with 3, and if you add up, then you should get 0. So I am assuming that, let's say this 0 0 is in this set S, then according to condition, if I multiply 5 with the first component, that is 0, and if I multiply 3 with the second component, that is again 0, and if I add up, then I should get 0. So yes, I am getting 0. So yes, this will be in this set S. First condition is checked and it is okay. Second condition is that if I pick any two vector, so let's say I am picking a vector, let's say a1 and a2, any two vector from this set S. So what my assumption is that this this belongs to, so this belongs to this set S, right? So my assumption is that this vector belongs to this set S. And let's say again I am picking another vector, let's say b1 and b2, and this also belongs to this set S, right? So if this belongs to this set S, then definitely it should follow this condition that 5 times the first component, that is a1, and 3 times this second component, that is a2, and if you add up, then you should get 0. And if this vector also belongs to this set S, then the 5 times of this component first and 3 times of this component second, and if you add up, then you should get 0. Now since I have picked these two vectors from this set S, now if I add these two vectors, let me add, and how you do the addition of vector? Component wise. So you can simply add the components of respective components of vectors and you will get this vector, right? Now I have to check this, if this is this vector, after adding, if this vector will belongs to this set S or not. So this I need to check. So if it is closed under vector addition or not, right? So what it is saying that if this addition belongs to this particular set S, then definitely this is going to satisfy this condition, right? Because that is the first criteria. So 5 times of the first component of the vector is this one, right? That is a1 plus b1 plus 3 times of the second component, that is a2 plus b2, right? And if we do the arrangements like 5a1 plus 3a2 plus 5b1 plus 3b2, then this should be this should come out 0, right? That is, if it is 0, then I can say that this vector belongs to this particular set. And if you look this thing, that is 5 times of a1 plus 3 times of a2, that is 0, right? So this is 0 plus again this thing is this 0, that will give you 0, right? So it was our assumption. What I have done, I have taken, and I have also told you that these two vectors belongs to this set S, and if these two vectors belongs to this particular set S, that is why this condition will be true, right? Now what I have done, I have simply added these two vectors, and now I am checking that if I do this 5 times of this first component and 3 times of this second component, and if I add up, I am getting 0 or not. So I am getting 0, that means this vector also belongs to this set S. So what I can say that this is closed under vector addition. Now the third condition that we need to check, that if I pick any vector from this set S, let's say I am picking a vector, let's say u1 and with second component u2, and if I do the scalar multiplication where alpha belongs to some real number, then the resulting vector I am getting this alpha times u1 and alpha times u2. And also you need to very careful that what you are saying, that this vector belongs to this set S, that means this definitely will satisfy this condition that 5 times of first component plus 3 times of second component, that is 0, right? This is your assumption. Now what we need to check, that if we take the scalar multiplication of this vector, then whatever you are getting should also be in the set, that means should also satisfy this condition. So if I check this one, how I can check? 5 times of first component plus 3 times of second component that should be 0. So we have here some infos, right, that we can make use of. So 5 times of, we can take alpha common easily, right? So that will give you 5 times of u1 plus 3 times of u2. That will, so this is 0, right, from here. So alpha times 0 is 0. So from here what I can say, that yes, this vector also belongs to this set S. What we have done, we have simply picked a vector that belongs to this set S, and we checked that under this scalar multiplication it is satisfying the condition that after doing the multiplication, whatever the vector we are getting, again this vector belongs to this particular set S. So this is closed under scalar multiplication. So all these three conditions has been satisfied, so we can say that this vector is a subspace of R square. Since this was the first question, that is why I took the time to explain each and every step. Now the second question, again we have the different set, and we just need to find that if this S is a subspace of R square or not. So you can easily see that what kind of vectors or what kind of elements, and those elements are nothing but the vectors, will be in this set, right? So one of the element could be, if I have to write, so this A is any number, so I can, so one of the element will be -3 and 5, right? So this will belong to this set S, right? So A I can take 0, so 0 0 will definitely belongs to this set. So the first condition is true. Second condition, that if I take any vector, any two vector from this particular set, so any two vector, how I can take, so let's say that -3 times of some c1, because if you look at the vectors in this particular set or the elements of this set, all these vector, the first component is getting multiplied by -3 and the second component is getting multiplied by 5, right? So if I have to pick another element from this set, then I can pick like this, -3 times of c1 or maybe 5 times of c1, right? There has to be c1 here also and here also, because this form needs to be followed, right? Otherwise I cannot say that if it belongs to S or not, right? So definitely this vector will also belongs to this set S, because this is the form, similar form, right? And let me pick one more vector, -3 times of a1 and 5 times of a1, right? So this vector will also belong to this set S. And if and here c1 and a1 is any real number, right? And this a is also any real number. So if I add these two vectors, so again these two vectors belongs to this set S, right? Now if I add these two vectors, that is 3 times c1, you should know that how to add two vectors. Here we will have 5 times c1 and 5 times a1, right? Now I need to check if this vector belongs to this set or not, right? So we can write like this also, right? -3 times of c1 plus a1 and 5 times of c1 plus a1, right? So you see that this is nothing but again the same form, -3 times of first component, sorry, the first component is -3 times of some constant and the second component is 5 times of some constant. Here also you see again the same form, minus 3 times of some constant and 5 times of some constant. So I can say that if you pick any two vector, and that addition of those two vector will also belongs to this particular set S. So this is closed under vector addition. Now I have to check for the third condition, that it should also be closed under vector scalar multiplication. So if I take any vector, let's say u1 and u2, I cannot take like this because the form needs to be there. So minus 3 times 5 times, right? And if I multiply any scalar quantity or scale this vector, then whatever the vector I will be getting after this scalar multiplication, that needs to be also in this set. If it is in this set, then all these three conditions will get followed, and I can say that this set of vectors will is a subspace of R square, right? So again you see this is the same form, right? How you can see that this is the 3 times. So look at the first component, minus 3 times some constant. So minus 3 times some constant, alpha is some real number, u1 is some real number, and again 5 times some constant. So again here the second component is 5 times some constant. So it is closed under scalar multiplication. All these three conditions has been satisfied. So I can say that this vector, this set is also a subspace of R square. So yes. What about this? So let's first check out if 0 0 is there, 0 vector is there or not, right? So if you take 0 0, right, 0, let's say I am saying that this belongs to this particular set S, right? Then this needs to be satisfied, right? So 2 times the first component, so 2 times 0 plus the second component, that is 0, we are getting 0, but according to conditions we should have that should be equal to 3, right? So 0 0 doesn't belongs to this particular set. I will not go further, and I will say that this is not a subspace of R square. Coming to this question number 4, if this set is a subspace of R square or not. So we have this vector, the first component is A and the second component is 3 minus 2A, and A is any number, any real number. So I will check for 0 0. So if I take, obviously 0 0 will not be in this set, right? Because if I take any number, let's say I am taking A 0, so this first component will be 0 and this second component will not be 0, right? You will have 0 3. So for any value of A, you cannot have these two components 0, right? If you try to make this 0 second component, then this will be not 0, because in order to make this 0 second component, you will have to take A that will be non-zero, and here on the first position, first component, that will be non-zero. So 0 0 will not be there, or you can say 0 vector is not there, so this will not be a subspace of R square. Coming to this question number 5, we have to check this set is a subspace of R square or not with this condition. So whatever the vector or whatever the elements that is in this set S should follow this condition. So x square plus y square is equals to 0. So basically what it is doing, it is squaring the first component and is squaring the second component and adding those two components, and the addition should be 0. Now point to here, note that whatever the first component or whatever the second component will be there, their square will be always positive, right? So even if you take first component is -1 and second component is -1, right, their square will be positive, right? And again you have to do the square and plus do the sum, and there is only one element in this set if you look carefully, right? Because if you take any number that is greater than 0, then this condition will not get satisfied, and if you take any number that is less than 0, this condition will not get satisfied. So for this particular set, only one element is there, that is 0 0 vector 0, right? So in this particular set we have only one element. Is this a subspace? Yes, it is. We can have a subspace with only one element, and that is a 0 vector. So is this a subspace? Yes, because there is only one vector, right? So 0 0 is there, the first condition is satisfied. If you take any two vectors, so any two vector, what you can take 0 times 0 and 0 0, right? And if you do the addition of these two vector, you will get 0 0. So that is again under vector addition, and similarly it will be also under scalar multiplication, right? So is this a subspace? Yes, this is a subspace. Coming to this question number 6. So this will not be a subspace. You can directly see that if you this 0 vector will not be in this particular set. Take this 0 and 0, and if this vector is in this set, that means this condition needs to satisfied. So 0 square plus 0 square is not equals to 1. So this will not be a subspace of R square. So this is not a subspace of R square. Coming to this question number 7, if you just need to find that if this is a subspace of R square or not. So we are having the elements in this set, so such a way that whatever the vector you pick, the first component should be greater than equals to 0, and the second component should also be greater than equals to 0. So 0 0 vector will be there, right? Because we can take the first component greater than equals to 0 and the second component greater than equals to 0. Second, I can directly see that the third condition that will not get satisfied, that it will not be under scalar multiplication. Let's say, because you see that 1 1 will be there in this vector space, sorry, in this set, right? Because you see this 1 is greater than equals to 0, and this one second component is also greater than equals to 0. It is satisfying this condition. That means this particular vector is in the set of this, is the element of this set S, right? Now if I take some alpha that is equals to -1, and if I multiply this alpha with this 1 1, then what I will get is -1 and -1, right? So this, if this set is a subspace, then this should also be in this set, right? But if you see the condition, that should be greater than equals to 0, and this should be also greater than equals to 0. So you see this is not closed under scalar multiplication, so this will not be a subspace of R square. Coming to this 8, so x and y are a rational number. So in this set, all the elements or all the vectors, the first component is rational number and the second component is also a rational number, right? So 0 vector will be there, that is no problem. And if you take 1 1, right, so 1 1 will be also there in this particular set, right, so this is a element of this particular set. And if you multiply with this pi, so that will, what you will get is the pi. So this pi is nothing but a irrational number, right? So you are not getting satisfied, so this is not closed under vector multiplication, vector scalar multiplication, because you see the first component, that is x, is a irrational number, and the second component, that is y, is again a irrational number. So this is not a subspace. Coming to question number 9. So x and y, where x, y are any two numbers, so obviously this will be a subspace, and it is a subspace that is acquiring the complete vector space, right? So it is exactly same as the complete two-dimensional vector space. So this will be a subspace. Yes. Let's look more questions. Now let's quickly go through the question from 10 to 19. So we have given this set, and we just have to find this, if this set is a subspace of RQ or not. So if you look at this set, and we have all those vector that with this condition, so all those vector will be on this plane, right, because all those vectors would get satisfy this condition, right? And if you see, this plane is in RQ, right, and passing through the origin, so definitely this is a subspace of RQ. So that's, yes, this is a subspace of RQ. And if you want to go through and check the condition, so the first condition, that is 0 vector is in this subspace. Yes, if you take the 0 vector, and if you try to look at this condition, 5 times 0, 5 times the first component, that is 0, 3 times 0, 2 times 0, you will get the 0. So yes, definitely this 0, this element or this vector is in this set. Now you pick any two vector from this set and add those vectors, how we have done in earlier examples. So in earlier example, we were having the set of vectors, and all these set of vectors are from two-dimensional space, and now we have the set of vectors that belongs to some three-dimensional space. So the procedure will be same. So you are going to pick any two vector from this set that is going to belong from this set, and after addition, whatever the result you will get, that result you need to check that if it is in the set or not. If it is in the set, then definitely that will satisfy this condition. So after addition, just check if whatever the vector you are getting is satisfying this condition or not. If it is satisfying, then it is closed under addition. Similarly, you can check for the multiplication, closed under multiplication or not, right? So you can do that. If you are still not able to then you should go through the all three steps or the all three condition. Then once you have a good practice and you have the good understanding of subspaces, you can just look and maybe you can answer the question, most of the questions. Now the second question 11 is that we have this set of vectors, and a and b can be any two number. So we just need to find that if this s is in the RQ or not. So a and b we can pick 0 and 0. So definitely this will be 0, this will be 0, this will be 0. So 0 is there in this particular set. Now we can take any vector, two vector. So let's take any two vector that belongs to this set S. So I will try to keep the same form. Let's say any other constant, that is c, any other number, that real numbers, that c1 and maybe d1, and the second component I will try to keep this form, right, but with this different number, so that we have different vector from this particular set. And here we will have c1 plus c2, and here we will have 4 times c1 plus d2. Here we will have d1, 4 times of c1 plus d1. This is the one vector from this set, and it belongs to from this set S, right? And we can have e1 minus f1 and e1 plus f1 and minus 4 times e1 plus f1. Now if I add these two vectors, and this also belongs to this set S, right? Now if I add these two vectors, that c1 minus d1 plus e1 minus f1, that is the first component. The second component will be c1 plus d1 plus e1 plus f1, and the third component would be minus 4 times c1 plus d1 minus 4 times of e1 plus f1. Now I just need to check if this addition is whatever we have got after adding these two vectors, that belongs to this set S. After addition, this vector also should belongs to this set S. So I will try to make this as a similar form that we have here in the set. So we can write is this one like this c1 minus f1 plus not like this, so we can write here c1 plus e1 minus times of d1 plus a f1. So you just need to rearrange so that we have this kind of form. So this will be again some constant, let's say a, and this will be again some constant b. So we are having this form. Look at this first component. Similarly we can do for this c1 plus e1 plus here we will have d1 plus f1, right? So these are the same, and you can do for minus 4 times of c1 plus e1 and plus d1 f1, right? So we have the same form, right? So this addition also belongs to this particular set S, and you can again check for the scalar multiplication also, so that will also belongs to this set S. And yes, this is a subspace of this R cube. Look at this question number 12. So we have the set of vectors, and all these set of vectors are satisfying this condition. And if you look at this, this is nothing but a plane, but this plane is not passing through the origin. That means if we try to pick this vector that have the component, all component 0, then obviously this plane is not passing through the origin, then 0 0 0 will not get satisfied. And if you are not able to visualize this, just take vector 0 0 0 and try to satisfy this condition. You will see 0 is not equals to 3, right? So 0 0, that 0 vector is in the set, that is why this is not a subspace of R cube. Question number 13, we have just these vectors with these components, and a and b are any two numbers. So a and b could be any two numbers. So this will also be not a subspace because a 0 vector will not be there. Try to do that. You just what we are trying to do. So you will not find any number a and b simultaneously such that you will get here 0 0 and 0, right? You can try. You just need to find it, this is equal to 0, this is equal to 0. Just find a and b such that we have all three components 0. You will not able to find, right? So 0 vector is not in this set, so that is why this is not a subspace. is this vector foot is this set is a subspace of R cube? Yes, this is a subspace of R cube, because if you look at this set S, it will have only one vector in this set, right? If you try to pick any elements, any component of this vector that is greater than or less than 0, then this condition will not get satisfied. So similarly what we have discussed here for this case. So this is again, this will be, yes, this will be a subspace, right? Because if we have only one vector, that is 0 vector, so 0 is a subspace. 0 vector is itself a subspace because it contains the 0, it is closed under vector addition, it is closed under scalar multiplication. So yes. Is this a vector space? No, it will not be a vector space because 0 is not in this set. Take 0 0 0, so it will be 0 plus 0 plus 0, and 0 is not equals to 1. So this is not a subspace of RQ. Is this a subspace of RQ? No, it will not be a subspace of RQ. Take any vector that is 1 1 1, right? So this vector belongs to this particular set because this condition is getting satisfied. You multiply the first component, multiply the second component, multiply the third component, and you will get 1 which is greater than equals to 0. Now let's check scalar multiplication. Just multiply here with some alpha, and let's say alpha is equals to -1. So what you will get is -1 times -1 times -1. Now multiply this component x, y, z. What you will get is -1, that is less than equals to 0. So this condition is not getting satisfied and it is not closed under multiplication. So this is not a subspace of RQ. Is this a subspace of RQ? So this is very easy to answer this question. This is a plane passing through origin, right? And whatever the vector you pick from this plane, that will belongs to this set. But we have additional condition that we should have this x, y, z such that at the same time we should satisfy these two equations. How I can see? I can easily see that this is a subspace. This is also a subspace of 3-dimensional space, and we have the intersection here. So the intersection will also be a subspace, right? So yes, this set will be a subspace of RQ. If you are not able to see this through this explanation, then what you can do, you can simply check if this 0 0 0 0 vector belongs to this particular set or not. So yes, it will belong, because if you take x 0, y 0, z 0, and let's look at these conditions if these are getting satisfied or not. So if you take 0 0 0, so this will be 0, this will be 0, this will be 0, so 0 equals to 0, and at the same time this will be also 0. Now next you can check under scalar multiplication. So you can do easily, and you just need to check after multiplying with the scalar quantity, whatever vector you will get, that needs to satisfy these two conditions, and that will get satisfied. And you can check for again the vector addition, closed under addition, and that will also get satisfied, right? So this will be a subspace. You can check it, right? If you have any problem, let me know in the comment section. Maybe in next video I will be explaining if you have any problem. And those who have a good picture of subspace, right? So we are in the 3-dimensional space, and this is a plane passing through origin. Again, this is a plane passing through origin. We will have, so here and is there, right? So the intersection of these two planes will be a line, and that line will also pass through origin. So yes, a line passing through origin will be a subspace of vector space R cube. So this is a sub this is a yes, this is a, sorry, I wrote no, so this is, yes, it is a subspace of R cube. Question number 18 is we have this kind of vector and a is any number, so you can easily look at this. So this is nothing but the a times of this vector, that is 2 minus and minus 4. So it is a vector in three-dimensional space. Let's say this is this vector, and what we are doing, we are just multiplying a scalar quantity, so we are just scaling this vector, right, and it will pass through the origin. So yes, this is again a subspace of R cube. And if you have doubt, simply what you can do, you can check all those three conditions. Question number 19, as we have this vector set of vectors and such a way that x, y, z are any three numbers. So x, y, z is any three number. So this space or this set of vectors will be entire vector of R cube, or you can say we are talking about a subspace that is itself a vector space. So this is a subspace, yes.